Designing accurate data entry procedures, systems analysis and design, Kendall and Kendall 8th edition. Learning objectives, understand the uses of effective coding to support users in accomplishing their tasks. Design effective and efficient data capture approaches for people and systems. Recognize how to ensure data quality through validation. Articulate accuracy advantages of user input on e-commerce websites. Effective coding. Coding aids the system's analysts in reaching the objective of efficiency because data that are coded require less time for people to enter, and thus reduce the number of items entered. Human purposes for coding. Keeping track of something. Classifying information. Concealing information. Revealing information. And requesting appropriate action. Keeping track of something. Sometimes we want to merely identify a person, place, or things just to keep track of it. For example, a shop that manufactures custom-made upholstered furniture needs to assign a number to a project. When keeping track of something, we can use simple sequence codes. The simple sequence code is a number that is assigned to something if it needs to be numbered. Sequence codes should be used when the order of processing requires knowledge of the sequence in which items enter the system or the order in which events unfold. We can also use alphabetic derivation codes. At times, it is undesirable to use sequence codes. It is commonly used approach in identifying an account number. Classification information. Classification affords the ability to distinguish among classes of items. Classifications are necessary for many purposes, such as reflecting what parts of a medical insurance plan an employee carries, or showing which student has completed the core requirement of his or her coursework. In classification information, we can use classification codes. Classification codes are used to distinguish one group of data with special characteristics from another. Classification codes can consist of either a single letter or a number. They are a shorthand way of describing a person, place, thing, or event. We can also use block sequence codes. The block sequence code is an extension of the sequence code. The advantage of the block sequence code is that the data are grouped according to common characteristics. Concealing information. Codes may be used to conceal or disguise information we do not wish others to know. There are many reasons why business users may want to do that. For example, a corporation may not want information in a personal file to be accessed by data entry workers. When concealing information, we can use cipher codes. Perhaps the simplest coding method is a direct substitution of one letter for another, one number for another, or one letter for a number. Revealing information. Sometimes it is desirable to reveal information to specific users through a code. In a clothing store, information about the department, product, color, and size is printed along with the price on the ticket for each item. This information helps the salespeople and stock people locate the place for the merchandise. When revealing information, we can use significant digit subset codes. When it is possible to describe a product by virtue of its membership in many subgroups, we can use a significant digit subset code to help describe it. The clothing store price ticket example in the figure is an example of an effective significant digit subset code. We can also use mnemonic codes. Mnemonic codes is a human memory aid. Any code that helps either the data entry person remember how to enter the data or the user remember how to use the information can be considered mnemonic. Requesting appropriate action. Codes are often needed to instruct either the computer or the decision maker about what action to take. Such codes are generally referred to as function codes, and they typically take the form of either sequence or mnemonic codes. Function codes. The function that the analyst or programmer desires the computer to perform with data are captured in function codes. The figure shows example of a function code for updating inventory.
General guidelines for coding. First, be concise. Codes should be concise. Overly long codes mean more keystrokes and consequently more errors. Long codes also mean that storing the information in a database will require more memory. Second, keep the code stable. Stability means that the identification code for a customer should not change each time new data are received. Third, ensure that codes are unique. For codes to work, they must be unique. Make a note of all codes used in the system to ensure that you are not assigning the same code number or name to the same items. Fourth, allow codes to be sortable. If you are going to manipulate the data usefully, the codes must be sortable. Fifth, avoid confusing codes. Try to avoid using coding characters that look or sound like. Sixth, keep the codes uniform. To be effective and efficient for humans, codes need to follow readily perceived forms most of the time. 7. Allow for modification of codes. Adaptability is a key feature of a good code. The analyst must keep in mind that the system will evolve over time, and the coding system should be able to encompass change. And 8. Make codes meaningful. Unless the analyst wants to hide information intentionally, codes should be meaningful. Effective codes not only contain information, but they also make sense to the people using them. And lastly, using codes. Codes are used in a number of ways. In validation programs, input data is checked against a list of codes to ensure that only valid codes have been entered. Effective and efficient data capture. To ensure the quality of data users enter into the system, it is important to capture data effectively. Data capture has received increasingly greater attention as the point in information processing at which excellent productivity gains can be made. So, first to do in capturing data is deciding what to capture. The decision about what to capture precedes user interaction with the system. Decisions about what data to capture for system input are made among systems analysts and systems users. Second, letting the computer do the rest. When considering what data to capture for each transaction and what data to leave to the system to enter, the systems analyst must take advantage of what computers do best. It can automatically handle repetitive tasks, calculate new values from input, and store and retrieve data. Example for this is this table. A table of codes used in a drop-down list. This list is used to select a code for adding or changing an item in a record. Next is avoiding bottlenecks and extra steps. A bottleneck in data entry is an apt illusion to the physical appearance of a bottle. Data are poured rapidly into the wide mouth of the system, only to be slowed in its neck because of an artificially created instance of insufficient processing for the volume or detail of the data is being entered. Next is starting with a good form. Effective data capture is achievable only if prior thought is given to what the source document should contain. The data entry operator inputs data from the source document. This document is the source of a large amount of all system data. Lastly, choosing a data entry method. Several efficient data entry methods are available, and choosing one of them is shaped by many factors, including the need for speed, accuracy, and user training. So under this data entry method are the keyboards. Keyboarding is the oldest method of data entry, and certainly it is one with which organizational members are the most familiar. And the optical character recognition. It lets a user read input from a source document with an optical scanner rather than off the magnetic media. It can speed data input from 60 to 90% over some keying methods. There are also other methods of data entry. First is the magnetic ink character recognition, which it can be found on the bottom of bank checks and some credit card bills. Next is mark sense forms. It allows data entry through the use of a scanner that senses where marks have been made on special forms. A common usage is for scoring answer sheets for survey questionnaires. Next is the barcodes. Typically appear on product labels, but they also appear on patient identification bracelets in hospitals and in almost any context in which a person or object needs to be checked into and out of any kind of inventory system. Lastly is the RFID, or the radio frequency identification, which it allows the automatic collection of data using RFID tags or transponders that contain a chip and an antenna, ensuring data quality through input validation. Validating input transactions is largely done through software, which is the programmer's responsibility. But it is important that the systems analysts know what common problems might invalidate a transaction. There are three main problems that can occur with input transactions. First is submitting the wrong data. Second, submitting of data by an authorized person. And the third is asking the system to perform an unacceptable function. Validating input data. It is essential that the input data themselves along with the transactions requested are valid. Several tests can be incorporated into software to ensure this validity. And there are 8 possible ways to validate input. First is test for missing data. Second, test for correct field length. Third, test for class or composition. Fourth, test for range or reasonableness. Fifth is test for invalid values. Sixth, cross-reference checks. Seventh, test for comparison with store data. And lastly, setting up self-validating codes. The process of validation. The order of testing data is to first check for missing data. The process of validation. The order of testing data is to first check for missing data. Then a syntax test can check the length of the data entered and check for the proper class and composition. Only after the syntax is correct are the semantics or meaning of the data validated. This includes a range, reasonable, or value test, followed by the check digit test. Accuracy advantages in e-commerce environments. So there are 4 accuracy advantages. First is customers keying their own data. Second is storing data for later use. Third, using data through the order fulfillment processes. And lastly, providing feedback to customers.